All right. So if you were gone for these yesterday, what we are trying to do on a problem where we've got like large amounts of exponents, let's see, Hudson, pass this back, you can go get your stuff. So when we have large exponents like this, we want to try to reduce the value of the exponents in order to create what we're calling a similar quadratic. And the way that we did that is, as long as your lead coefficient has a variable with an exponent that is even, you can rewrite that exponent as a quadratic. Because if you divide this number by 2, that would be the same as p to the 5th power to the 2nd power. And using the power rule that you learned back in algebra 1, the power rule says if you multiply the exponents together, if you have a power to a power, you get back to the original. So 5 times 2 is 10. So 10 divided by 5 is 2, making that squared, which is a quadratic. So we're going to do the same thing here. If we were to rewrite this one as a quadratic, we would take our x to the 8th power, divide it by 2. We'd first look for a GCF. There isn't one. You'd think there would be with those large numbers, but there isn't. So we take 8 divided by 2 to get 4. So we're going to say that x to the 4th power is equal to some other variable y, or z, or a, just not x. We used x in the first one because x was not part of the original polynomial. But with b, c, and d, x is part of the original polynomial. So when we use substitution, we can't use x for this. X to the 4th equals x is not a good way to go. So over here, we're going to write y squared. And the reason for that is, 625 y squared, keep a coefficient. Because if y is equal to x to the 4th power, y squared would be x to the 4th power squared. 2 times 4 is 8. So it works. And then minus 256. And then what we're going to do is try to factor that. And just so you know, this is a difference of squares. 625 is a perfect square. Y squared is a perfect square. 256 is a perfect square. What's the square root of 625? 25. So that would be 25y, because we square root both of those. What's the square root of 256? 16. So 25y plus 16 times 25y minus 16. Difference of squares. All right. So then, I think that's it. So we're going to go back over here. And we're going to rewrite the original value of y, which is x to the power of 4. So we're going to say 25x to the 4th power plus 16 and 25x to the 4th power minus 16. Now, in the previous 3 problems, A, B, and C, we were done at this point because we couldn't continue factoring, but the directions at the top do say to factor completely. What do you notice about 25x to the 4th minus 16? Is 25 a perfect square? Is x to the 4th a perfect square? Is 16 a perfect square? Is it subtraction? Yeah, that's another difference of squares. So the 25x to the 4th plus 16 we can't factor because it's the sum of squares, which isn't a thing in terms of factoring. So we're just going to say 25x to the 4th plus 16. But over here, we're going to be able to say 5x squared plus 4, and then 5x squared minus 4, because this is also a difference of squares. And then from there, we're done. If this coefficient, though, was another perfect square, we would have had another difference of squares because x squared is a perfect square and so is 4, and there's subtraction, but 5 is not a perfect square, so we're done. So this is our answer for part D. So we factor using a little bit of substitution, rewrite the problem with the original values of x and its exponent, and then recognizing that that is also a difference of squares, rewriting it like this. Questions about that process before we look at the last 2 problems? All right, flip it over. Let's get this done. So on the next page. Now, I'm glad that I've been mentioning the whole thing about what is a factor and what isn't. And I mentioned, it doesn't really matter if it's a factor or not. It just is or isn't. But the fact that you know that now is going to make these a lot easier. Because if this is a factor of that, then this would divide evenly by that, right? Meaning there would be a remainder of what? Something's a factor. What's the remainder? 0. So what we're going to do is use polynomial division I would recommend synthetic division because that is useful here. Because this is a binomial. It is linear. There is no coefficient other than 1, so we can use synthetic division. And I would recommend dividing this by this. Using synthetic division, if you want to use long division, you can. But as long as the remainder is 0, that means it's a factor. If the remainder is anything other than 0, it's not a factor, which you learned about a couple days ago when we did polynomial division. So here we go. If x minus 2 is equal to 0, what's the value of x we have to use? 2, yeah. So 2 goes on the outside of our large upside down division symbol. And then the top row, what are our 3 values going to be for the top row here? 1, 2, and -4. Good. The coefficients of the quadratic, the linear, and the constant value. All right. Bring down the 1. You can draw the arrow or not. You don't have to draw the arrow. Bring down the 1. Multiply 1 times 2. Add. Multiply again. 2 times 4 is 8. -4 plus 8 is 4. Remainder of 4. Is it a factor? No. There's a remainder of 4. If it was 0, it would be a factor. So we're just going to say not a factor. All right. That's how we do those. Let's try the next one. What's our value on the outside of our division? -5. All right. Set up your synthetic division. How many coefficient values are we going to need up here? 5. Good. There are 4 terms here. We need 5 coefficient values. We have our quartic coefficient of 3. We have our cubic coefficient of 15. We have our quadratic coefficient of -1. We have our linear coefficient of what? What is it? 0. Yeah, there is no linear term. Bless you. There's no linear term, therefore, linear coefficient is 0. We do need that. And then we have our constant value of 25. All right. We're doing a count, spirit count. Red, white, or blue. Red, white, or blue. You've got red on and blue. Oh, wait, we got to differentiate between classes, right? Freshmen? Freshmen? Yeah, sophomores? Go ahead, sophomores, stand up if you got red, white, or blue on. Okay. Oh, is it okay? 3, 6, 9. Okay. Red, white, or blue. Because of Veterans Day. Yeah. Juniors. Oh, okay. I think it's 9 or 10. No, it was 10. It was 10. It was 10. Juniors. So 3 as well. So we got Kate here too. Seniors. 2 seniors. All right. And I got to tell you, this was not on purpose. And neither was the American flag on the shoes. Like that was on accident, but it happened, and I'm glad it happened. So put the staff down for 2, you know, cook the books a little bit. All right. Bring down the 3, right? What's -5 times 3? -15. What's 15 plus -15? 0. What's 0 times anything? What's -1 plus 0? -1. What's -5 times -1? 5. What's 0 plus 5? 0 plus 5 is 5. What's 5 times -5? -25. What's 25 plus -25? 0. So is it a factor? Yeah. It is a factor. All right, cool. How's synthetic division feeling these days? Not bad? Okay. Next one. Oh, this one's a little bit different. Show that x plus 3 is a factor, which there is an implication there. The implication is that this is a factor of that. If it tells you to show something, that means it is. So first of all, it's telling you this is a factor of that. So if you do synthetic division and you get any other remainder other than 0, you know something didn't go quite right. So we're going to do synthetic division, and then we're going to factor this completely. By the way, the synthetic division is going to help with the factoring, just so you're aware of that. Let's get this going. What number do we do on the outside of our division? -3. All right, let's set that up. We're going to have how many coefficients? 5, again, good. So we have our quartic of 1, our cubic of 3, our quadratic of 0, linear, -1, constant, -3. Drop down the 1, multiply, -3, add, 0, multiply, 0, add, 0, multiply, 0, -1, +3, and 0. So when we write this out, this is our constant term. This is our linear. This is our quadratic, and this is our cubic. So what we're saying is that x to the 4th plus 3x cubed minus x minus 3 divided by x plus 3 is equal to x cubed minus 1. Because these are both 0. So that means that the two things that are factors would then have to multiply to equal the original polynomial, correct? So like this, x plus 3 times that, x cubed minus 1, those would be the two things that we're multiplying to equal that. So that's what we're going to do. We're going to take x plus 3 and then we're going to take this. Use blue so we don't get our lines crossed too badly. And we're going to write that over here as another set of parentheses. And that's going to say x cubed minus 1. Those two things multiplied would equal this. If we were to use FOIL and FOIL this out, we would end up back here. However, we're not done yet. This tells us to factor completely. Now, if you were gone yesterday, I wouldn't expect you to recognize this. But if you were here and you didn't notice it, shame on you. I'm just kidding. Let's take a look at our second page of notes real quick. Second page of notes, we had a couple of rules for the sum of two cubes and the difference of two cubes. So if you look at the second set of parentheses that we just did, what form does that show up as? Does it show up as a sum of cubes? Shows up as a difference of cubes, because x cubed is the perfect cube of x and 1 is the perfect cube of 1. So what we're going to do is we're going to use this rule here with the problem that we are working on right now. I'm just going to grab a different page of notes here and put these two things side by side. All right, so here's our rule. And then here's our current polynomial. So the cube root of each of these will be our values of a and b in terms of what we're looking at. So a is the cube root of x, which is x, and b is the cube root of 1, which is 1. So we're going to start this off. By the way, the x plus 3, nothing we can do with that, so that's just going to remain x plus 3. However, the x cubed minus 1 will turn into a minus b in one set of parentheses, which would be x minus 1, because x is a and 1 is b. So x minus 1. And then the next set of parentheses will have a squared. X is a, so a squared would be x squared. Then we're going to add the product of a and b, x times 1, or 1x, or x, so plus x. And then we're going to add b squared at the end, 1 times 1, which is 1. So we're using synthetic division. We are writing out the result of that because it is a factor, what we're dividing by and what the answer was when we divided it. And then we're looking at this and using our difference of cubes rule to finish up the factoring. So multiple parts going on here. So definitely look for those different things that we have, difference of cubes, difference of squares, perhaps. If something is just factorable, like you'd still need to check to see if you could factor this. It doesn't, but you still need to find out. Because you'd be looking for two numbers that multiply to 1 and add to 1, which doesn't exist. Not in terms of whole numbers anyway. The only two numbers that multiply to equal +1 would be +1 and +1, or -1 and -1. And if you add those together, you either get +2 or -2, not +1. So at this point, we're done. So you have multiple things going on there. All right, last one. Same type of problem. I'm going to be a little bit quicker with it. X minus 2 means that our value on the outside of our division is 2. We're going to set up our synthetic division. We have our quartic, we have our cubic, our quadratic is 0, our linear is 1, and our constant is -2. We're going to bring down the 1. We're going to multiply 1 times 2, which is 2. Add those together, we get 0. 0 times 2 is 0. 0 plus 0 is 0. 0 times 2 is 0 again. 0 plus 1 is 1. 1 times 2 is 2. -2 plus 2 is 0. So first of all, we've shown that this is a factor because the remainder is 0. It told us it was a factor. We showed it. We're good. So then we're going to have our constant, our linear, quadratic, our cubic. We're going to take our original thing that we divided by, which is x minus 2. And then we're going to multiply that by the answer of the division, which is x cubed plus 1, because x squared and x have coefficients of 0, so we don't need to worry about writing those. So x cubed plus 1. And that is the sum of cubes, isn't it? Sum of two perfect cubes. So once again, a is equal to x, b is equal to 1. We get the same values for a and b, but this time we're using the first rule instead of the second rule, sum of perfect cubes instead of difference of perfect cubes. So this will be x minus 2, and then that'll be a plus b, so x plus 1. This is still a squared, but instead of adding a times b, we're going to subtract a times b, so that'll be minus x, and then we're still going to add b squared at the end plus 1. And then we run into the same thing that we did on the previous problem. There aren't two numbers that will multiply to +1 and add to -1. So at this point, we are finished. There we go. Which is actually a really good way to jump into the next lesson.